Hello YouTube, this is UMails03. So we made it to lesson 24 of the Java curriculum, more than halfway through at this point. I'm planning on about 40 to 45 videos, probably 42. So anyway, we've been talking for 2 videos now about object-oriented programming. So first, in 2 videos ago in lesson 20, lesson 22, we created this person class, and we said basically we can create our own data type. So here we create our own person class, and we said first thing we have to do is declare private instance variables, and here we have 2 of them. One of them is a string and the other one is an int. Then we have a constructor which assigns them. So we say name is equal to the n that the programmer passed in when they created the person object, and age is equal to a, which is the integer that the programmer passed in when they created the object. One video ago in lesson 23, we also talked about how we can have different types of constructors. So not only can we have the freedom to pass in the person's name and age, and just, not only would, we don't have to require that they pass in both of those things, but we could also have a type of default constructor where essentially we have the programmer pass in fewer of the parameters, and instead we give more default values. So in the previous video, we said, what if the programmer didn't pass in the name or the age? And we said, well, what we could do is basically we could say that the name could just be Claire and the age could just be 29. So we could basically just make those values default. And then we had I don't know what you could call this one. You could call it like a halfway default constructor, because it has one parameter, but not both of them, right? This would be a default constructor, and this would be a parameterized value. And so it's kind of half of both. And then you could even have another type of constructor down here where you just pass in their age. So what if you only know how old they are? And then you could say something like, oh, their name is Mary Scott, and then their age is equal to A, so whatever they pass in. And then down here, remember, we also talked about getter methods. So that was in our introduction in lesson 22. And that's when we were talking about the getName method and the getAge method. So you have to view the return types here, right? So the getName method should return a string, and the getAge method should return an int. And those data types line up with the data types that we see up here when we declared those instance variables. So we know that name is a string, and we know that age is an int. So if we're going to be returning those values, then the method types need to line up with that. So here we just return the name if we call the getName method on a person object, and we return the age if we call the getAge method on a person object. So hopefully that's clear to you. And these are called static methods because they don't stand alone. These are called on a particular object. They're not like an f of x is x plus 4. That would be a static method where you can just, pop in an x and out comes the x plus 4. But here, these are a little bit more intrinsic to an object. So they're called instance methods, and that's why you don't write static. You just write public, data type, and then the name of the method, and then any inputs that might come in. But for getter methods, usually there are no inputs. But for setter methods, usually instead of returning something, instead of outputting something, instead of retrieving something, we're inputting. We have to give information. So here we're passing in a string, and we would assign the person's name to whatever string n is passed in after the object has already been created. So this is not a creation of the name. This is a modifier after the object has already been created. Same thing for age. So hopefully you're clear on that, and if you're not, then it would be discussed at length in lesson 22, and maybe also reviewed a little bit in lesson 23. But those are void methods because they don't return anything. We have a public string toString method, and essentially what that does is it allows us to print an object. So I wanted to give you a little bit more detail about what that means. And you can see I was watching my own YouTube videos here, and I was just kind of testing them out and making sure that they successfully made it onto YouTube. But what we're going to do is we're going to go to the String Java API, and we've seen this before, but I wanted to show you one of the methods of the string class, because we've already seen this before. But if we go to the toString method, we see that the object is itself returned for a string object. We talked about that in lesson 5, I think. But if we go to the object Java, basically what we're going to be talking about eventually is inheritance in a few videos from now. And there's essentially an object class that every class that we create is a subclass of, and it has a toString method. And so essentially, if you don't include a toString method, one of the things we saw in the previous video is when we tried printing an object, it kind of had this weird @ symbol, and then it had, I think, a few digits and a few letters. So basically, the toString method would return a string that textually represents the object. So it's a string consisting of the name of the class, of which the object is an instance, the @ character, and the unsigned hexadecimal representation of the hash code of the object. So that's not very clear. So that's why we create a toString method to basically override that and define what it means when we print an object. So hopefully all those things are clear. And then we have a separate person tester class where all we have is a main method. And we simply, we can create person objects, and we have 2 person objects here. One of them calls the constructor where we feed in just the name and the age is default. And the other one calls on the completely default constructor where we feed in nothing, and both the name and age are default. And we tested out the toString method because we don't have to call a.toString. We can just call system.out.println of a, and out would come what did we have? So for if you pass in just a string, I think we had a default age of 53. And if you didn't pass in anything, we had a default name of Claire and a default age of 29. So if we go ahead and print, then we get these 2 things right here. Okay, so we just get the Kevin is 53 years old and the Claire is 29 years old. So you see that here. So in this video, what I wanted to talk about is a keyword called this. So what this does is it basically would allow you to pass in a parameter that coincides with the instance variable name. So here, if I say person of string name, here the problem with doing that is name already refers to the instance variable. So if I say name equals name, then which name, what would be what, right? Because this name on the left, I would want to basically be referring to the instance variable that I'm trying to assign. And the name on the right is the name that I want to pass in. But in order to prevent ambiguity here, what you need to do is you need to write this.name equals name. And so that would mean that this refers to your instance variable that you're assigning. And then the name on the right-hand side of this equal sign is the name of the parameter that you're passing in. So you can do the same thing down here with this. If you wanted to, for the setter method, you could just say string name. I want to set the name, but then here you would have to say this.name equals name. So either way, but it just prevents the ambiguity because on the left you have the instance variable. So you need to say this.instance variable equals, and then on the right-hand side, you just have the parameter. So it would just be name. So hopefully that's clear to you and you can understand why we have that keyword, because otherwise you just say name equals name and Java wouldn't know which is which. So either you have to make them different, or you have to use the this keyword, or you can do both. Okay, so a lot of times what I've seen like professors sometimes do in universities when I tutor other kids is essentially they will do both. So what you could do is you could have a different parameter and you can say this. So this is, I guess it's kind of redundant, right? Because here, this.age, it's referring to the age instance variable, but there's no ambiguity because the number that we're going to make the new age, we're calling that X here. So here, I mean, there's no problem with doing this, but you have to do one or the other, right? Either you have to say age equals something other than age that you're referring to, or this.age equals age. So hopefully that's clear to you. The other thing I wanted to talk about is public and private and static and instance. Okay, so we want to talk about the difference between methods here. So there's different ways to characterize the types of methods that we have here. So if we want to talk about a static method, remember a static method is essentially a standalone method. So if I go into the person tester class, we talked in lessons, let's see if I can get it right. So lessons 20 and 21 about static methods, and we created a static method, right? So what we could do is say something like this. So we could have an isOn method of a boolean that returns a boolean, and we could accept a string, right? And we could say something like return y.length greater than 0. Okay, so this is a pretty trivial method, but basically this would just return whether or not a string is not empty, whether or not it has characters in it. So this would be equivalent to return not y dot is empty. We talked about that method in lesson 5, that simply just returns whether or not the length of the method is 0. So this one, obviously the length either is 0 or greater than 0. So this is a static standalone method. So this one, you could just call it. You could say boolean k equals isOn of hey. Okay, and so of course this if you said system.out.println of k, we would of course expect that to return true. But the point is that this is a static standalone method, and we wouldn't have to create a person tester object in order to use the isOn method. So let me show you what I mean by that. If we go ahead and compile, and now we go ahead and run this main method, we see that true here, right? Because we said that the method returns true if the length of the string that we pass in is greater than 0. But here, if we return an empty string, then of course we would get the false here, right? That's why we have a false here. So if we go ahead and make this method an instance method, we would not be able to call this isOn method without creating a person tester object. Okay, so this method now, this isOn method is literally intrinsic to the person tester class. So now we could not use the method, and you can see there's an error thrown and we cannot compile the program. So let's figure out why. Because it's valid, right? We're passing in a string and the method is right here. isOn, we spelled it right, and we're returning a boolean, so it's the problem. So here it says non-static method cannot be referenced from a static context. So the only thing you would have to do is you would have to create a person object. So what you would do is our person tester object. So you would say person tester sample equals new person tester. And then what that would allow you to do is now you can call this instance method on the sample object, right? So now you can say boolean k equals sample.isOn of empty string. So hopefully that's clear to you. This is the difference between a static and an instance method. Is an instance method operates on an instance of a class. Okay, so basically, remember when we were talking about, like, if you have a person Tom equals new person of Tom and 82. And then if we go ahead and change Tom's age, if it's a birthday, for example, if we say Tom dot set age of 83, this is an example of an instance method because we had to create a person object in order to call the set age method, okay? But if we want to create a static method from the person class, we can go ahead and do that. So let's create a static method from person. Now we're back in our main person class, which is what most of our focus has been on. So now we do a public static double u. So we're just going to create a static method that accepts no inputs, and it's just going to return 89. Okay, but we know that 89 is going to come out as 89.0 because this method is instructed to return a double. So now what we can do is, since this is a static method from the person class called u, which returns a double, I'm going to go ahead and go to person tester, and down here I'm going to say system.out.println of person.u. So what this does is a static method just belongs to a class as a whole, whereas an instance method is called on an instance of a class. So now if we go ahead and want to have that 89, which I'm saying is going to come out as 89.0, hopefully we're going to see that in the bottom. And indeed the 89.0 comes out because we called the u method of the person class, but this is a static method, which means that we didn't have to create a person object in order to use the u method. We created person objects up here, but we didn't call u on any of them. We just called u on the person class. The last thing I want to talk about is public and private. So what I said in lesson 22 is that usually we make our instance variables private. So name and age, we would not be able to call name or age directly from outside of the class on a person object. So let's try doing that. So what we would do is we would say person, well, we could, let's just reassign Tom. So you can see the Tom up here, and we're just going to, we'll keep his name the same, but we're just going to, well, that's all right. In order to prevent confusion here, I'm just going to say person W equals new person of Sam. Okay. And then what I'm going to do is I'm going to say system.out.println of w.name. And then we're going to try to compile. The problem here is we have an error here which says name, that name has private access in person. And so that's the difference between a public and a private method. Because here, public or private method or field. Because here, now we're back in our person class. And here, if I nestled in a main method for my person class. Remember, we already have a main method in the person tester class, but now if we go back into the person class and we make a separate main method, here we would be able to call name or age directly because those are private variables, so they can be accessed from inside of the class, but not from outside of the class. So if we said person P equals new person of Pat 30, and then we said system.out.println of p.name minus 7, this would not be, or let's see what happens here. So p.age minus 7, why am I subtracting 7 from a name? So here we would compile, and then we go ahead and close. And then if we run the main method of the person class, we are able to get 30 minus 7. But when we tried running .name here, it was an issue because it says name has private access in person. So hopefully that clarifies the difference between public and private access. Is that essentially if we have public, that means that we can call those methods or those attributes from outside of the class. Here we have a separate class way over, way down here, and we can refer to person because anything that we're doing with person is public, like the getAge method and the setName method. But if those fields themselves, if the instance variables themselves are declared private, then we need to be careful about that. And that's why we need to set up public getter methods. And that's just good etiquette. It's good convention in computer programming. So hopefully that was helpful, understanding the difference between static methods, which are called on a class, and instance methods, which are called on an instance of a class. And we'll say a little bit more about that in the next video. And also the difference between public and private methods and fields. And then also the use of the keyword this to prevent confusion between an instance variable and a parameter that you're passing in. So being able to say name in two different contexts. So hopefully that's helpful, and I'll see you, and we can talk more in the next video. So from Umoso3, thanks for watching, and please subscribe.